We use the same rules for multiplying in algebra that we do in basic math. So you're going to need to know them. Let's take a look at them. There are basically 5 properties of multiplication, and you'll need to know them. There's the multiplication property of 0, the multiplication property of 1, the commutative property of multiplication, the associative property of multiplication, and I told you there were 5, the distributive property, and really the distributive property is called the distributive property of multiplication over addition. It uses both. Let's take a look at each. The first one, the multiplication property of 0, I bet you already know, but we'll need to use this in algebra. In plain language, the multiplication property of 0 is anything times 0 is gone. Anything times 0 equals 0. Very simple, isn't it? So 5 times 0 is 0. Even x times 0, I said anything times 0 equals 0. Anything times 0 equals 0. Okay, so that's a first. That was an easy one. What about the second property? The second property of multiplication is the property of 1. When we talk about multiplying by 1, anything times 1 is going to equal itself. So 5 times 1, of course, equals 5. X times 1, don't let it scare you, is going to equal x. Even times 1 equals I don't even know what it is, but if I multiply it by 1, I get itself. Okay, that's 2 down. What about the commutative property of multiplication? We'll use this in the future as well. That is, you're allowed to switch, hence the word commute. You're allowed to switch the order of the things getting multiplied, the factors, when you multiply. So 5 times 7 is the same as 7 times 5. Note we switched them, didn't we? Ooh, this has 3 things. 2 times 10 times 3, order doesn't count, is the same as 10 times 2 times 3. Note I switched the 10 and the 2.
Excuse me?
Okay. You don't have to switch everybody. As long as you switch anything, the reason is to switch the order is a commutative property. See that we flip those? Now note that this switching doesn't work for all the operation. It works for addition and it works for multiplication. It doesn't work for subtraction and division. For instance, 7 minus 5 is not the same as 5 minus 7. 7 minus 5 is 2. 5 minus 7 is not 2. It's negative 2. Okay? Don't need to worry about that right now. All you need to know is that you can't switch it. And 10 divided by 5 is not the same as 5 divided by 10. So we can't flip we can't flip subtraction and division, but we can commute multiplication and addition. The next property is often confused with the commutative property. It's the associative property of multiplication. Because the order of something changes. It's just not the order of the terms. When you're multiplying more than 2 things, so 3 or 4, usually 3, you are allowed to do them in any order. I say you're allowed to multiply them in any order. It doesn't matter which 2 you associate first. Now note this problem here. 2 times 10 times 3. We're going to say that that's the same, obviously, as 2 times 10 times 3. Now I note that the order did not change here. 2, 10, and 3 is still in the same order, 2, 10, and 3. But the parentheses are telling me to actually execute a different part of the problem first. On the left side, I multiply the 2 and the 10 first. I'm associating a different thing now, 2 and the 10, and getting 20. On the right side, I'll associate the 10 and the 3.
Just as I suspected.
But look at both sides. 20 times 3, 60, will be the same as 2 times 30, 60. So it really didn't matter which 2 I did first. And note I didn't change the order of the terms. It's still 2, 10, and 3. 2, 10, and 3 on both sides. It's the order that I executed the multiplication. Now, like other operations, this or like other properties, this doesn't work for subtraction and division. It only works for addition and multiplication. For instance, here, if I change the order,
Oh, no you don't.
I'm going to get different answers, as you can see. If I do that on the left side, the 10 minus 7 first, I'll get a 3 minus 2, I'll get 1. But on the right side, if I do the 7 minus 2 first, I get 5, and that's a completely different answer. 10 minus 5, that's 5, okay?
You're way off. I say you're way off this time.
So this associative property only works for multiplication and addition, not for subtraction, and also not for division.
Now then, boy, we'll see how much you learn.
Let's see if you can tell the difference between two statements that have the commutative and have the associative property. In this state, why is this statement true?
A clue.
Well, let's see. Look on the right side and what changed. It started off at 7 times 3 times 5, and it became on the right side 3 times 7 times 5. What changed was that the 3 and the 7 changed order. Who tells me I can commute the 3 and the 7? It's the commutative property. Okay? Let's do another. Now this one has parentheses. This is a tricky one though. Let's look at 2 times 4 times 5, and on the other side 2 times 4 times 5. Oh no, I'm sorry, 2 times 5 times 4. The parentheses did not change, did they? The parentheses did not change. When the parentheses changed, it's associative, but they didn't change. What changed was the 5 and the 4. I tricked you. This one, again,
Excellent.
is a commutative property. This one, the parentheses changed, didn't they? But the order did not. This is 2, 4, and 5 on the left side, and 2, 4, and 5 on the right side. The only thing that changed was the parentheses. See how the order stayed the same, but the parentheses changed?
Yes.
That's the associative property. You can see why people get confused. So when the order of the factors changes, it's the commutative property.
Darn tootin'.
And when the parentheses change, it's the associative property. Got it? Now we have one last property that you'll need to know, and it's probably the most important of all. That's the distributive property, also known as the distributive property of multiplication over addition. Basically, what it says is,
Well, isn't that special?
it is the one special exception to the order of operations. What the exception is that in this situation, and I'll show you this one situation, you don't have to do what's in parentheses first. Now you could do what's in parentheses first, but you don't have to. See where we could add the 3 and the 4 first. But we're also allowed to distribute the 2 to each of those. Now 2 is multiplying, and the 3 and the 4 are adding. Hence you see the multiplication over addition. So we're going to distribute the 2 to the 3, and also to the 4. And then do it. 2 times 3 plus 2 times 4. It's another way to compute this. In this one, instead of adding the 5 and the 6, we could distribute the 10 to the 5 and add that to distributing the 10 to the 6. Now you got to say to yourself, why would I do this? Why would I ever do this? Well,
I'm sorry. I'm afraid I can't do that.
there is going to be a time when you can't do what's in parentheses first. For instance, in this situation, we can't do x plus 5. I don't know what x plus 5 is. They're unlike terms. But the distributive property allows me to distribute that 10 to the x and get an answer, and distribute it to the 5 and get an answer. And that's what they expect you to do when they say distribute. Okay, it's going to allow me to do a little bit more. But it is, make no mistake, an exception to the order of operations, which you should have memorized by now. We're going to be using multiplication, so let's make sure that you know how to do some long multiplication. Let's take that 2, and I'm only going to do 2 numbers at a time. I'm going to multiply it by 2 times 9 first. Now I'm going to look at the 8, and what will I get? I'll get 18. I'll keep that in my head. Now I can only write one numeral down there. So I'm going to write the 8. And what do I do with the 1? Well, the 1 really isn't a 1. It's a 10 because it's in the 10 spot. So I'm going to carry it over to the 10 spot and remember where it was. Now I'm still going to multiply 2 times 8, get 16, and then what do I do with the 1? Add it to the result, and now I'll write that, 17. And that's my answer.
Excuse me, Professor Brainiac.
This we call partial products multiplication. Fancy word. Remember, products is the answer to a multiplication problem. All that's saying is that we're going to do part of the problem at a time. Okay, we're going to do the 2 first, then we're going to do the 5. Watch. Let's do the 2 first. We just did one very much like that. 2 times 9 is what? 18. And I write the 8. Carry the 1. Now 2 times 8, not done with the 2 yet, is what? 16. What do I do with the 1? Add the 1 and get 17, and then I'll write the 17. Now I'm done with the 2. Whose turn is it?
Played it for her, play it for me. Play it.
That's the 5's turn. Now that's really a 50, isn't it? So I'm not going to start writing my answer under the 8. Because it's a 50, I'm going to start writing my answer under the 7. 5 times 9 is 45. Let's put the 5 under the 7. Like I say, that's where we're starting. Because that 5 really is a 10. It really is a 50. That was 45, and I'm going to carry the 4 from the 45 up here. Okay, now I've got to go 5 times 8. I get 40. What do I do with the 4? Just like before, add him to the result, and I'll write the 44. Now, I have 2 parts of the answer, partial products. Let's add them together. 8 and nothing is 8. 7 and 5 is 12, so I write the 2, carry the 1. 1, 1, and 4 is 6, and then 4 and nothing is 4, and there's your answer. Not so bad because we do a little bit of it at a time. Okay, now I'll expect you to show that work on the tests. Obviously you can check it with a calculator, but I want to make sure that you show that work. So you have to show your partial products, like the 178 and the 445 that you see there. If you don't show it, no work, no credit.
Oh, man.
Let's get to it. Do the homework.